Hello guys, it's good to be back. Kylem here. In this episode, I'll be talking about chemical reactions and chemical equations. These topics you can get to learn these topics from any of the science textbook of class 10, and you will find it in chapter number 1. Now, chemical reactions and chemical equations, they are of the same thing, because chemical equations are the mathematical representation of chemical reactions. You can write these chemical reactions in the book in the form of chemical equations. So chemical equations and chemical reactions, they actually mean the same thing. So we will be talking about the chemical reactions and chemical equations. Now, what are chemical reactions? Chemical reactions are, as the name suggests, is a reaction that results in chemical change. Now, there are two types. When we talk about the change, chemical change and physical change and chemical change. But we will not be talking about physical change. We will be talking about chemical change only. Physical change means if you break a glass, it is a physical change, because the pieces of glass, the broken pieces of glass, remains glass only, not something else, but it is glass only. Now the glass cup may be broken, but it is still glasses, the pieces of glasses. So it is a physical change. If you break a stick, the pieces of sticks, if you break a stick into two, then both the broken pieces of a stick, they remain as stick. So it is a physical change, because the results are the same chemically. But if you cook a rice, then the rice before you cook and the rice after you cook, they are different in composition. That is why it is called a chemical reaction or chemical change. Or if you burn a paper, then before you burn a paper and after you burn a paper, the paper remains different, and it is said to be changed chemically. So it is called that kind of change is called chemical change. Most of the physical change, you can renew, you can reverse it, which means that after you do the thing and before you do the change, you can interchange it. So supposing if you press if you press a rubber ball and make it change the shape, then if you release the pressure on the rubber ball, it retains its shape. So it is a physical change. If you put air in the balloon, then before you put air in the balloon, it is smaller, but after you put the air in the balloon, it is bigger. So it is a physical change. But you can undo that. You can make it smaller by releasing the air. So it is a physical change. But once you burn the paper, you cannot make into paper again. You cannot turn it into paper again, because it is chemical change. So these are basically the basic and the most important difference between this physical change and chemical change. We will be talking about the chemical change. Now, chemical change can be obtained by making a change into that change, and that process is called chemical reactions. And the mathematical representation, in order to write this chemical change in a book, you will be needing these chemical equations. Now, chemical change can be of change in state, change in color, and change by giving out the gases, or change in temperature. So this is how we can bring a chemical change. Let's talk about the chemical equations. As I've said, chemical equations are the mathematical representation of chemical reactions. We will learn about chemical equations. Now, chemical equations, we can simply distinguish the equation by looking at the structure which will be divided by an arrow sign like this. It's not only arrow sign, there can be a double headed arrows, but here in simple term, for simplicity's sake, we can simply understand the chemical equations by looking at this kind of structures divided by the arrow sign. Now let's learn about how to write a chemical equation. Before we learn about how to write a chemical equation, we will just know about it again. So in chemical equations, as I've said, since they are the mathematical representation or the description of a chemical reactions, it will comprise. It will contain chemical equation will contain the molecules, the compounds before reacting, and the products. Okay, the molecules or the compounds after reaction. So before reaction, the compounds that are formed before the compounds usually on the left hand side before reaction, these are called reactant, and after reaction the compounds formed are called products. So reactant and product, that's the two things. And if the reactant and the product are the same thing, are similar in number, when the number of reactants, when the number of molecules in a reactant is equal to the number of molecules in a product, it is called a balanced chemical equations. So anyone can just write out the chemical equation, but if it is not balanced, then it is not quite a suitable one, or the reaction may not be possible to ever occur. So it is an error chemical equation. So all written form of chemical equation cannot necessarily occur. So that's why we have these balanced chemical equations. In these balanced chemical equations, you will most probably you will find that the number of participating elements and the compounds will be the same from the right hand side to the left hand side. Supposing this is a chemical equation, the reaction between zinc and sulfuric acid. When zinc and sulfuric acid reacts, it forms zinc sulfate and hydrogen gas. Now if we write the chemical equations word by word, then it's going to be very long. Some reactions are really long and massive, so it's going to occupy a lot of space and it's not convenient. So in order to simplify the equations, we have to make use of the symbols of the elements and the molecule, such as this zinc is represented simply by Zn, and sulfuric acid, its molecular formula, sulfuric acid is represented by H2SO4. And similarly, a zinc sulfate, we can represent zinc sulfate instead of writing zinc sulfate like this, a long name, a long word consisting of two long words, we can simply compress it into one simple and very short word. Okay, not really a word, but it is a very a compressed form. So ZnSO4, Zn is for zinc and SO4 is for sulfate, so zinc sulfate. And hydrogen, we don't need to write this HYDROG like that in spelling form. We simply represent this hydrogen by H or H2. Now how do we know that this chemical equation is balanced or not. We will be able to know that this chemical equation or any chemical equation that it is balanced or not by making a table such as this table. Such as this element on the one side, and in another column the number of atoms, and in third column the number of atoms in the products, because the reactant group will be different from the product group, as I've said, because the reactant group will undergo a change to form a product, but the product may be different, but number of atoms, number of the group, okay, the identity group or the molecule will be the same. If it is not the same, then it shows that there is an error in your chemical equation. An errorless, a correct chemical equation will have the same number of identity group both in both the reactant and the product, which means that before reaction and after reaction the number of participating identity will remain the same. That's what it means. Now here you can understand that what I mean by simply looking at it. Now here zinc reacted with the sulfuric acid here to form zinc sulfate and hydrogen gas. Now we can represent this one in this table, as I've said, in written form like this. So here to check out in the reactant list, zinc is 1, and again in the product zinc is 1. Hydrogen was 1 in the reactant. Before reaction hydrogen was 1, and after reaction hydrogen also becomes before reaction hydrogen becomes 2, and after reaction hydrogen becomes 2. Sulfur was 1 before reaction, and after reaction sulfur becomes 1 again. So it's the same. It's not like before sulfur it was 1 and after reaction sulfur it becomes 2 or 3, not like that. Before also and after also the number of the identity will remain the same. If the sulfur is 1 before reaction, after reaction it will be 1. If oxygen is 4, then it will be 4 only. So if it is like this, then it is called as the balance equation or balanced chemical equation, and it is the correct form. So how do we make it into a balanced equation? How do we learn? How do we do that? So in exams we will find the imbalanced randomly written chemical equation, and we have to make it equal by balancing it. So it involves several steps. So let's learn those steps one by one. Now they have given this one. Supposing this is the equation that is given in the exam. So we have to balance this equation. Now this equation is the given equation is the reaction between the iron and water. So when iron reacts with water, it forms iron oxide and hydrogen gas. So iron oxide, this Fe3O4, it is the molecular formula for the iron oxide, and it is also called iron oxide can also be called as ferrous oxide, because the ferrous and ferric it means iron, and it is represented by Fe. Now in step 1, how do we start at all to balance this kind of equation? Number 1 step is to write down the identity. Now Fe is iron, so iron we have to write down in one box like this, such as this box. So here it is iron. We have to separate this iron. We have to separate this iron in a box by writing, putting it in a separate box. So iron is one identity, and H2O. This is H2O is water. You cannot write this H in one group, one box, and O in another box, not like that, because H2O, it is the molecular formula for iron. So this H2O, we have to write it in a box. We have to put it in a box such as this box. Now another, in the product side, we come across this Fe3O4. Now Fe3O4, this one also we have to write it in one box. And H2, it is also, we have to write it in another box, separate box, such as this. After we put those particular identity in the boxes, we have to list down what are the elements that are involved in these boxes. For example, here Fe, it is iron, so we just write it directly, because in the product there is iron oxide, so we don't need to write. We will extract the elements here. We are, the next step, we are writing the pure elements, not the molecule. The first step is to identify the identity group. Okay, identity group can be of element, pure element, or of compound or molecule. And the second step is to break down those molecules into constituent element, pure element. So the first one here from the left side and the right side, it has this iron, so we are writing iron. And after that we have this H, which is hydrogen, so we are writing this H here. And here again oxygen is there, so in oxygen O we have written here. Now in the product also it does the same thing. Iron is here, oxygen is here, and hydrogen is here. So we are writing those three elements here. Iron is also here, hydrogen is also here, and oxygen is also here. Now after that, the next step is to write down how many iron are there, how many hydrogen are there, how many oxygen is there, those things. In the first column, we are writing about the product before reaction. So in before reaction, we have this iron. We have only one iron, and we have two hydrogen here. That's why we are writing here 2, and only one oxygen. That's why we are writing here 1. Now let's see about after reaction. After reaction, iron here, iron Fe3. Fe3 means iron is 3. So that's why iron we are writing here 3, and hydrogen here H2. So H2 means two hydrogen. So we are writing here 2. And here oxygen O4 means 4. That's why we are writing here 4. Now we can compare this one. We can compare this table. This is if we compare this table, we see that this iron is iron before reaction is 1, after reaction is 3. Hydrogen remains the same, no problem, and oxygen before reaction 1 and after reaction 4. So which means that this is an imbalance. It is not equal. We have to make it equal. No, if we just add some more number here and just make it equal, it is not going to be enough. We are going to do it similar to that one, but not really like that, but similar to that. We have to make these numbers equal. Which means that here iron we have to make it 3. Hydrogen we have to make it no changes, no necessary. Oxygen we have to make it 4 here instead of 1. So how do we do that? Let's see. We will do that in the next, by doing the next step. Now if you look at this equation, we are writing in the equation again. Before the equation was very plain and simple. Fe plus H2O, like that. So instead of here H2O, instead of writing H2O, we'll just put here 4. Why do we put this 4 here? I will explain to you. Why do we put here 4? We put 4 here because oxygen is 4. So the only way to make oxygen 4 on this reactant is to add 4 here, is to put 4 here. So here 4, if we put 4 here, then this 4 also covers up this O. So that's why it's a mathematical representation. So it's we are talking about the mathematical language here. So this 4 covers up this O, just like A plus B whole square, like that. The square, the 2 covers A and B also. So just like that, we are covering this 4, the whole H2O. Okay, which means that this 4 means that this hydrogen is also having this 4, and oxygen is also having this 4. So here oxygen will have 4 and the hydrogen, it will become 8. 2 into 4, 8. Here you can simply understand that here oxygen, it is having 1. Okay, so 1 into 4 is 4 and 2 into 4 is 8, like that. So here we don't need to worry about oxygen anymore because oxygen is already leveled. Here on the right hand side we have this 4 oxygen and left hand side we have 4 oxygen. Now we have to worry about the other thing, such as this iron. Iron is still unequal. Now okay, before we make the iron equal, we will just make the hydrogen equal, because now in the third step, what do? We have added 4 here. So 4 here, which means that hydrogen, it becomes 8, but this side, on the right hand side, hydrogen is only 2. So we have to just put here 4 again, so that hydrogen will become 8. So what they have done, they have put 4 here. So we can put so now hydrogen is 8 on the right hand side, and even in the left hand side, hydrogen is 8. So hydrogen and oxygen is equal. Now the only thing we need to do is make this iron molecule equal on both the sides. So on the right hand side we have 3 iron, and on the left hand side we have only 1. So how do we make it equal? By adding here 3. If we just write 3 here, then it will become 3 iron on the left hand side, and even on the right hand side it will become 3 iron. So the next one is like this. It will look like this. We have added 3 here. Before we have added 4, and after 4 we have added again here 4 on the right hand side for this hydrogen molecule, and the last one we have added 3 here for this ferrous, and it will look like this: 3 iron plus 4 H2O water. It will result in 1 ferric oxide and 4 hydrogen. Now this is complete, and this is balanced equation. It is called as balanced equation. It is balanced because from the before reaction and after reaction, all the molecule, all the identity groups, they are same. They are showing the same thing, equal numbers on both the sides. So it is called as balanced equation. Now this is not yet complete. So in order to make this equation a complete one, we have to indicate this identity group, whether it is solid, whether it is liquid or gas, by simply assigning. If it is solid, then we have to write S. If it is liquid, then just L, and gas, then G. So the last step is to assign this identity into their separate state, whether it is solid or liquid or gas, like that. So iron, 3 iron, we will indicate this iron as solid by writing S, and water as gas, and ferric oxide as solid, and hydrogen gas as gas by writing S. So this is it. This is how we are going to balance up all different kinds of whatever the chemical reactions that are there. We can balance, we can make those equations balance by following these rules, by following these steps. So we have learned about the change, the that is the chemical change and chemical reaction, and we have learned about the chemical equations and even how to balance those chemical equations. Now let's learn about chemical what are the different types of chemical equations. Now these chemical equations can be of different types. Again, types of chemical reactions here. Number one type of chemical reaction is combination reaction. We will learn about this combination reaction first. Combination reaction is the chemical reaction combination reaction. Combination reaction, as the name suggests, is very simple. It involves combining, combination of the identity of the reacting molecules. Now, such as this example I have given here, this quicklime, calcium oxide. Quicklime, when reacts with water, it results in combining both this quicklime and water. Both this calcium oxide and water will combine into one form. It will become one thing. Okay, that is why it is called as combination reaction, because it combines. This 1 and 2 reactant react and combine into to form the product. It is called combination reaction, because it combines, as I've said. This quicklime and water, it combines to form slag lime. That's why it is this kind of reaction. This type of reaction is called combination reaction. It forms the slag lime, and by giving off heat, it will produce heat. It will produce heat in combination reaction of this quicklime and water to form this slag lime. Now the next type of chemical reaction is even redox reactions are there, but we will go in hand by hand. And the first one we have learned about the combination reaction. We will learn about the displacement reaction. Then the next one is displacement reaction. These are all examples of combination reaction. Displacement reaction in here. Displacement reaction. Okay, before displacement reaction, we learn about this type of reaction, that is decomposition reaction. Decomposition reaction, as I've said, as the name suggests, decomposition reaction, it involves decomposing of the identity of the reactant. Decomposition. Now, if you allow your dead rat to rot, it will decompose, and slowly it will turn into a soil. It will decompose. So that kind of reaction is called decomposition reaction. Supposing the example is given here, the reaction between this ferrous sulfate and ferric oxide. The ferrous sulfate, when you heat it up, it will result in ferric oxide. It will give off the sulfate. Sulfate groups. Here they have given this ferrous sulfate. This is one identity, and it will decompose to form two different groups. Actually, three different groups here. So this kind of reaction, it is called the decomposition reaction. Ferric oxide, ferrous sulfate, one identity, one group. When you heat it up, it will decompose by this decomposition reaction to form this ferric oxide. Disulfate, and trisulfate. So this kind of reaction is called as decomposition reaction. The next one is displacement reaction. Displacement reaction is also very simple. Is, as the name suggests, it involves in displacement of the reactant participating element or molecule. Displacement means changing of position. When position is changed from one group position to another group position, it is called as the displacement reaction. Such as this example, the example of this displacement reaction, it is here. When iron reacts with copper sulfate, then this sulfate SO4 group, this sulfate group from this copper sulfate, the sulfate group from the copper sulfate, it will go to the ferrous, the iron group. That is why it is called as the displacement reaction. Sulfate group from copper sulfate, it will change the place and go and join this iron group to form iron sulfate. So this kind of reaction, it is called the displacement reaction. And if there are double displacement going on, it is called as double displacement reaction. Such as this group, when sodium sulfate reacts with barium chloride, then the sulfate group from the sodium group, it will go to barium group and form barium sulfate, and the chloride this chlorine group from the barium group, it will go to sodium group to form sodium chloride. So double displacement going on. From the chlorine from the barium group, it is going to sodium, and even from the sodium group, the sulfate has gone to barium group. So changing of the groups going on. So this kind of reaction is called the double displacement reaction. Not single displacement, but double displacement reaction. And after that, the last chemical reaction is oxidation and reduction. Oxidation and reduction reactions, they are also similar to any of those above mentioned reactions, but they are isolated in the way that they involve the taking in and losing of oxygen molecule. So in simple way, if the identity group loses oxygen, it is called as reduction, and if the identity group, if the reactant gains oxygen, then it is called as oxidation reaction. But if a reaction has both losing, also one group is losing the oxygen but another group is gaining the oxygen, so oxygen is losing also and gaining also. If the reaction has that kind of situation, then it will be called as redox reaction. Such as the reaction of this copper oxide and hydrogen gas. Copper oxide and hydrogen gas, when reacted, then the copper will be left alone, which means that this copper oxide reacts with hydrogen gas to form copper and water. So this copper oxide, it is reduced, so it is reduction. It has undergone the reduction reaction. But this hydrogen group, it gains oxygen, so it is called as oxidation reaction. And both oxidation and reduction going on, happening in the same reaction, same equation, it will be called as redox reaction. As simple as that. And you have observed the reactions in the daily life. We will learn about the corrosion. When we have this iron bar outside, the fresh iron bar left outside, exposed to rain and water and the heat and sun, it will turn into some different color. That is because of the rusting. And that rusting, it is because the iron, it is getting mixed with the oxygen in the from the air. So the oxygen from the air, it is getting into the iron and oxygen from the air, it combines to form the rust. So it is also oxidation reaction. And another one is that the food or the fruits, or the eatables, which has these fats and oils, the fresh food that we have, that contains the oils or fats, it will become unfresh. The smell will turn, the odor and the smell, it means the same thing. The smell will turn, and the smell will, the good, very good smell, food items can be turned into a bad smell food item. That is because of the oxidation. When the oxygen from the air gets mixed and combines with the fats, then the smell will turn. That is because of the oxidation reaction. And that phenomena, the spoiling of the smell of your fats or an oil containing food, it is called as rancidity. So this rancidity is also due to oxidation, and corrosion is also due to oxidation. And that is why in the chips, in Uncle Chips, in the chips, we have, when we buy the chips, in the mica, we have, the pack contains lots of gas, and that gas is hydrogen gas. No, nitrogen gas. The company has put the nitrogen gas in those packets in order to prevent the spoil of the chips, the food item. In order to avoid the oxidation reaction in the food item, they have put this nitrogen gas in the food packets. That's why we get this loss of air in the food packets. So this is the end of this chapter about the chemical reactions and chemical equations. So I hope that everybody understood, and if there's any questions, you can post it and comment it and call it up for more information and clarifications, and all the necessary questions and answers based on these topics. You will get it, and you get it in your textbooks and in your notes given notebooks, and even through some other media or through your friends. Now, in case of any doubts or incomplete information, or somewhere you have stumbled upon something else, you can always ask, and feel free to call and feel free to comment. So thank you so much for watching the video.